Okay, so I'm going to demonstrate how to do a total runout measurement. What we'll need is a dial gauge with preferably with a resolution of a micrometre. You'll probably get away with 2 micrometres, but if you want to have a bit more certainty about your measurement, you should probably invest in getting a better dial gauge if you've only got a 2 micrometre one. So we've got a dial gauge, we've got 2 precision V blocks. We've got the rotor mounted in the V blocks with some Vaseline to lubricate it. We also have a straight edge, which I've mounted against the V blocks here. So that just butts up against the plane at the edge of the V blocks here. It's important that that obviously sits flush and there's no gap. So what the measurement relies on is that the plane at the edge of the V blocks is aligned with the journal axes, defined by these journal cylinders. So we have got a kind of a dodgy arrangement on our dial gauge. We've set it up on another V block because it's nice and flat and square. Obviously you can't have this thing rocking around. It's on our CMM table here, so it's a flat granite table, flat to a micrometre. But we don't want this thing rocking around or rocking against the straight edge because it'll mess the measurements up. So we found this is okay, but you might want to make something slightly more rigid to mount a dial gauge. So what we do to do a total runout measurement is we start off at a particular point on the rotor. So we butt it up against the straight edge here, the V block, or the upside down V block that I've mounted the dial gauge onto. So there it is, butted up against the edge. And we want to find a reference point to start with. So I'll rotate the rotor in the V block to point 2A. So it's now pointing at hole 2A. It's just 20 millimetres off to the right of it there. And then what we want to do is set a 0 point on the dial gauge. And now it's important to always spin, we've found, the rotor in the same direction. So I'll spin it round and we'll just check that when 2A points to when the dial gauge is pointing at 2A, we get a nice 0 on the dial gauge. Hopefully you can see that. That's reading 0 micrometres. So now we want to take some measurements. So we'll spin the dial gauge around, the rotor around, and we'll just see what the maximum excursion there is. Seems to be about 11 micrometres. So bring it back round and it goes back to 0. So already the run out at that point is 11 micrometres. So it's right on the threshold of not passing at this point already. And we know it doesn't pass because we've measured it on the CMM. So now what we do is we slide the dial gauge along the rotor. Okay. So you can see the reading there is about 4 micrometres on the dial gauge, and if we give it a spin, what's it going to go to here? Around about 20 micrometres. And it goes up to 2 or 3 micrometres. So far the run out is already at 20 micrometres. The total run out, should I say. So we'll go along to that's row 3. We'll keep going along our straight edge. give that a spin. So that's gone out to 30 micrometers at that point, back to 20. So this is a run out, according to this dial gauge, of 30 micrometers so far. But of course what we have to do to verify nothing's moved is we'll just run our dial gauge back along the rotor and check that we get a 0. We should get a 0 on 2A, which is where I set it up at. So we'll spin it back round and we're coming to 2A now. And there you go, 0 micrometers. So that was a total run out of about 30 micrometers. Now we measured, I think, about 21 micrometers on the CMM. We haven't checked the V blocks, so there may be some slight misalignment between the V and the plane. If you're worried about that, you could send us some V blocks and we can make a couple of measurements just to check the alignment of this plane with the V, to make sure that the journal axis is aligned nicely with that plane. That's probably where the error is coming in. It also depends quite a lot where we take a slice on the rotor and actually make the measurement. If we measure near the holes, you tend to get around about 25 micrometers, maybe a little higher. If we measure in other places, it's slightly different, obviously, but the drawing does say to make measurements near the holes, so that's what we've done in this particular case, and that's what we do with the CMM measurements as well. So yeah, I hope that helps. Yeah, as I said, one of the critical things is that this V block's nice and, whatever you mount it on is nice and flat and runs nicely along the straight edge, so that you don't get it jumping around and false readings on the dial gauges and things like that. So that's a total run out measurement.